Hi there, this is Electromagnetism lesson 3, and this one's on electromagnets. So we're going to describe how an electromagnet works. We're going to talk about how to increase the strength of an electromagnet. And there's quite a number of applications which we'll go through in some detail. So there'll be quite a lot of diagrams in this and quite a bit of learning, so it might take you a little bit longer than the length of the video, especially if you're pausing to get the relevant information down. So first of all, electromagnets. So an electromagnet consists of a current carrying coil wrapped around an iron core. So here's a very simple one. So we've got a power supply, we've got a nail, and then we've got a wire. So that would work as an electromagnet. Here's a beefier one. So obviously you can see the difference straight away. So we've got probably, well, with the thickness of the wires on the right, we've got much more electric current. We've got a big, thick core, and then we've got obviously a lot more windings of copper. So that'd be a significant upgrade. So let's look at the uses of electromagnets. So the obvious one, Scrapyard Crane. So the iron core of the electromagnet is a soft magnetic material, typically iron. Well, it says iron, so obviously. It doesn't mean it's soft, obviously. If that landed on you, you'd be in serious trouble. By soft, it means softly magnetic. That means that it's easily magnetized and easily demagnetized. It's very efficient at doing so. So when a current flows, the iron becomes strongly magnetized because it's a soft magnetic material, and so it picks up the scrap iron and steel. That's basically it. And then really important to be able to put it down when you want to move it, you just turn the electric current off, the iron loses its magnetization because it's a soft magnetic material, and it releases the scrap. Remember to pause to make notes at any point. Right, the electric bell. So, if you push the switch, so when the push switch is closed, current flows around the circuit, and it will turn on the electromagnet. What you've done when you've pushed the switch is complete the circuit. That's quite an important, examiner point there. If you say complete the circuit, or, if the circuit's incomplete, if there's no current flowing, etc. So there's the current. So as you can see, there's an electromagnet there, which is just a magnet with a coil around it. By magnet, I mean electromagnet. When the current flows through, it obviously becomes magnetized. So what it'll do is attract that soft iron armature towards it. So the soft iron armature is pulled towards the electromagnet, and the hammer will hit the gong. Notice what's happened now, though, to the circuit. Look at the contact switch. So now the circuit is incomplete. If the circuit's incomplete, there's no current flow, which means the electromagnet will switch off. So this causes the contact switch to open, cutting off the electric current. The spring will then obviously retract the hammer, pulls the armature back again, closing the contact switch, completing the circuit, repeating the process. So current now flows again, the hammer hits the gong again. All right, let's move on to the next one. By next one, I mean question. So write down 1 to 8, see if you can identify the components. So the first one is the electromagnet. Second one, switch. Third one might be a bit tricky, but that's the spring. Fourth one, the hammer. Number 5 is the battery or power supply. Number 6, soft iron armature. That's going to be attracted towards the electromagnet, so the hammer can hit number 8. Number 7, that's the contact switch. And number 8 is the gong. If you got all them, well done. If you didn't get them all, but got most of them, still well done. Right, let's move on to the next one. So next one's a relay switch. So a relay switch is a way of using a low voltage circuit to switch remotely, so from some considerable distance away, to switch on a high voltage circuit, which is potentially dangerous. So it's relatively straightforward. It's very similar to the bell. So close switch A, current flows through the circuit. It's now complete. So when switch A is closed, the small current provided by the cell or the battery or power supply causes the electromagnet to become magnetized. You can see to the right hand side of the electromagnet, we've got the iron armature, which is obviously going to be attracted towards the electromagnet. So the iron armature is then attracted to the electromagnet, causing the springy contact at the bottom. Switch B to close in the high voltage circuit, which then connects, a potentially dangerous high voltage circuit. And that's basically it. So same mechanism, Electromagnet attracts the iron armature, connects the circuit, connects a high voltage circuit that we don't want to be touching. All right, let's move on. So circuit breaker, exact same principle. So circuit breakers are the things in the house. So if your electricity cuts off, if there's a problem, typically too much current, circuit breakers will break the circuit, and stop any serious issues. So in normal operation, current would just flow through the circuit. So it'd go from point A through the electromagnet through to point B. However, if there's an issue, so when the current in the circuit increases, so if there's a problem somewhere, the electromagnet will obviously increase in strength. We should know that electromagnets, to make them stronger, you either need more coils or more current. If there's too much current, the electromagnet will pull the soft iron armature towards it. And as a result, the spring one pulls apart the contact, which disconnects the circuit immediately, thus stopping current flow. So there we go. Now we've got an incomplete circuit, which can't cause anybody any harm. So the reset button at the top, you just press that down. It'll bring the contact back to its original position, and you reconnect the circuit. So you've got domestic circuit breakers. You've got them in your house. They're probably downstairs somewhere, maybe in a downstairs toilet or a basement or a closet or whatever it is. But you've probably got this somewhere. Good things about circuit breakers is, that you can just reset them. So it's not like a fuse. A fuse would obviously melt and you have to replace it. And another good thing about circuit breakers is as soon as the current gets too high, they act immediately. So they switch off straight away. Whereas a fuse, for example, in a plug would, it takes a little bit of time for it to melt that wire. So circuit breakers are obviously very useful. Okay, close exercise. So you can attempt this. You can either write the full thing out, or you can just write 1, 2, 3, 4, 5, 1 to 7 and write some keywords in. If you want to attempt it without the keywords, please do so now. I'm going to share the keywords now. And then I'll take you through the answers. So a wire carrying an electric current produces a magnetic field. This field increases in strength if the current is increased. A solenoid is a coil of wire carrying an electric current. The field produced increases in strength if the number of turns in the coil is increased or if iron is placed inside the coil. An electromagnet consists of a coil of a solenoid wrapped around an iron core. Iron is a soft magnetic material that loses its magnetization once the current in the coil is switched off. So they're not permanent magnets, and they're softly magnetic, which means that they're easily magnetized and easily demagnetized. They're very efficient at doing so. All right, let's do if you want to carry on, I'm going to do a few exam style questions. So if you want to have a look at this one first. So the diagram below shows a door lock which can be opened from a flat inside a building. Explain how the door is unlocked when the switch is closed. So obviously what's going to happen, the switch inside the flat is obviously closed. So we get a complete circuit. So we get current flow. Current flows through the electromagnet, which is the iron core and the coil. The iron bar will be attracted towards it, and the steel bolt will be pulled out from the door. I'll put the mark scheme on as well. There you go, so you can check that. All right, let's move on to the next one. So state 2 changes which would increase the strength of the electromagnet. So this should be straightforward. So I'm going to put the answers on. More turns, bigger current. That's essentially it. You could say EMF. EMF, remember, is just voltage. Could use a softer iron core. The answers that are typically given in examinations, more turns, more current. All right, let's move on. Why is the spring needed in the lock? That's just to relock the door, so it'll spring back into place once you disconnect that circuit. All right, let's try this one if you want to pause and attempt this. So the connections to the coil were accidentally reversed. Would the lock still work? And explain your answer. So the iron bar would still be attracted, still magnetized. So yes, it would still work. And that's about it. Right, I've got one more question. So another explanation question. So if you want to pause and have a go at this one. So a fault in an electrical circuit can cause too great a current to flow. Some circuits are switched off by a circuit breaker. So it's the exact same principle that we've been looking at all of this lesson, just a different diagram. You obviously have to, there's quite a lot of information there. You need to figure out what happens. So one type of circuit breaker is shown above. A normal current is flowing. Explain in detail what happens when a current much bigger than normal flows. So in normal operation, we've obviously got current flowing through the electromagnet. If there's too much current, then obviously the electromagnet will increase in strength. Remember, there's two ways to do that. More coils, more current. So the iron bolt that's holding the plunger in place to the right hand side will obviously be attracted towards the electromagnet. The plunger that's being held in place with the spring, it says the spring is pushing upwards, will spring up and disconnect the push switch. There's a mark scheme. And obviously to reset that, you would have to get the plunger back down into place by resetting it. So circuit breakers are good, remember, they act instantaneously. So as soon as there's too much current, electromagnet switches increases in strength. The entire process happens nearly immediately, and you can simply reset them. All right, hopefully you found that helpful. Thanks for watching, and I'll speak to you soon.